So, today's topic we'll be continuing with the features you must know as per the placements or interview perspective. And also we will also be introducing object-oriented programming today. Okay. So with this note, let's get started. So last session, we started with features of Java language, also called as Java buzzwords. Uh, so this topic is important for both academics as well as for placements. So keeping that in view, I have just collected some of the important features, especially keeping uh, placements in perspective. We will be discussing some of the very interesting features of Java. Okay. Now we already seen a lot of things makes Java a great programming language. Last session, we discussed the history of Java programming language. I hope everybody have attended last session. Anybody missed a session? Let us know how can we help you so that you can go through with the last session. That could be great help for you. So after discussing the history, we started with the features of Java language. So we discussed like a lot of things that makes Java a great programming language for business and multimedia applications like platform independent, simplicity, versatility, robustness, etc. We will be talking all these things one by one today. We started with the very first feature, which is platform independent. And we had a very detailed discussion about platform independent. I told you like the internet was the major reason, right, for the development of Java, because we have seen like Java initially developed for electronic gadgets, but it was not working out. And there was a need of a language which is platform independent in internet application development, because can we have notes? Yes. As I told, like we will be providing detailed notes for all these things, but I will strongly recommend to, if you want, I can give some time. You can make some important points as a reference because that could be very important for interviews and placements. Okay. So definitely we will give you the notes at the end. You can have a reference for that. Okay. Now, uh, I told you like there was a need to be able to transmit applications from one machine to another over the internet, and there was no guarantee that the machine would be using the same operating system, right? Like for example, let's say uh, if I have write the program in C or C++, let's say you have a Windows operating system. Okay, let's say you have Windows operating system. If you write a code in Windows operating system, let's say you have written something like hello.c or hello.c++ program, okay, and what that like this source file will give it to a compiler, and what compiler will do, it will give you an executable file. Okay, it will give you an executable file, right? Now my question to everyone, can I run this executable file in Macintosh operating system? Can I run this exe file in Mac operating system? Can I run this exe file in Linux operating system? No, right? We cannot run this exe file in Mac, or we cannot run this exe file on Linux or any other platform, because whatever the exe file it generates, it's platform dependent. It's for Windows platform. So it contains the instruction set for that particular platform. I cannot run that in any other platform. So that is where we see like C++ are platform dependent. In the same way, let us write, let's say we have again a Windows operating system. Now this time I write something like hello.java. Okay, we write hello.java. And if I give this hello.java to the compiler of Windows running on Windows operating system, what that compiler will do, instead of generating that exe file, it will generate a dot class file, okay, which is a bytecode. It will generate the dot class file for you, which is a bytecode file. Now, once we generated this dot class file on Windows operating system, can I run this on Linux operating system? Can I run this on Linux operating system, this dot class file? Yes, we can run this on Linux operating system, but we should have a JVM present in this particular platform. Okay, so all platforms have this interpreter installed by default, which we call it as Java Virtual Machine, which runs this dot class file and converts into the native instruction set. So once we get this dot class file, I can run on Linux operating system. I can take this dot class file. I can run in Mac operating system. Okay, and or I can run in any platform. So that's why we have seen like Java is platform independent language. You can write once and run anywhere. Okay, you can write once and run anywhere. So you just need to have one dot class file to run on Linux, to run on Mac or any other platform. Just compiling it on Windows can run on any other platform. This feature is basically called as platform independent. Okay, so before we move to the next features, I have a couple of quick questions for you all. You all can answer quick questions and then we will go for the next features. Okay, so I have collected these from different companies. So let's see like what kind of questions these companies basically prefer from the concepts what we are learning. Okay, so let's say which of the following best explain why Java is called platform independent. Okay, so let's see what are the options. So option A says that Java source code can run on any operating system directly. Do you agree with this, Varun? Like Java source code can run on any operating system directly? Yes or no? What do you think, guys? Okay. Okay, let's see the other options and then we'll conclude at the end. So Java compiler generates the bytecode that runs on the JVM of any platform. Option C, Java code is converted into machine code of each operating system. What do you think, guys? Which option is correct? So let's see, like Java, first thing is Java source code can run on any operating system directly. Obviously, you cannot run the source code in operating system directly unless and until you convert into an executable file. So option A will be not correct. So the Java compiler generates the bytecode, right? Just now we have seen like the Java compiler will generate the bytecode and that bytecode can run on JVM of any platform. Like I just shown you that Windows will generate you the bytecode file, which is dot class file, and that can run in any platform which has JVM installed. Okay, like Linux or Mac or any other platform it can run. So option B is more close. Let's see whether option C is correct or not. Java code is converted into machine code of each operating system. It will not directly convert into machine code, right? It will be converted into bytecode. So option C will be wrong. Java compiler will not be directly converting into machine code. So as you have seen in the diagram here, that Java compiler will not going to give you the exe file as it has been done with the C++ compiler, whereas Java will not give you the executable file. Instead, it gives you the bytecode. So this is my bytecode. So it gives you the bytecode, which is nothing but a dot class file. Okay, which is nothing but the dot class file. So here option B is correct. Okay. Now, moving forward, we have seen like when Fortran, C or C++ code is compiled and linked on a given system, the result is an executable file that can usually be run only on that particular system. So we have seen like how C++ are platform dependent because the source code I write here, if I compile on a platform one, I get an executable file for that particular platform. If I compile on other platforms, I'll get the executable file for a specific platform. I cannot run the executable file for one platform on other platforms. So with this, we can say that they are platform dependent. So you cannot compile uh, a program on Microsoft Windows machine and run the executable under Macintosh operating system. So this way we can say that C and C++ are platform dependent. Whereas in Java, we have seen, let's say we have different platforms. Again, let's say we have Windows, we have Linux, we have Mac. Then if I give this source code to Java compiler, the Java compiler will give me a bytecode. Now, bytecode directly we cannot run on machines, okay, because they don't understand this bytecode, because bytecode is Java's own instruction set. Bytecode is Java's own instruction set. So we cannot run this bytecode directly on any of this platform. Okay, so we have to have JVM installed on these platforms. So the Windows JVM is responsible for converting into Windows executable. Linux JVM is responsible for converting into Linux executable, and Mac JVM is responsible for Mac executable. So we have only one bytecode, but we can run on any platform because of Java Virtual Machine. So Java Virtual Machine is installed on every platform. Its responsibility is to read the bytecode file and convert into native instruction sets. Okay, convert into native instruction sets. Now I would like to wait here and see if anybody having any question. I get first question here. Is JVM is built in every system? Yes, JVM will be by default available in almost every platform. Okay, so you don't have to worry for it. So it will be there with every system. Or when you actually install JDK, Java Development Kit, the JVM comes with the Java Development Kit, which can be compatible with the particular platform. Okay. So is your question got answered? Can we see if anybody else having any question? So this is which version of Java should we download? I'll show you which version we will be going with. I strongly recommend go with the latest version, but at least when I am teaching here, I'll start with minimum 7th version, because there are a lot of enhancement with the 7th version of Java. Then slowly we will proceed with the other versions, and we will see that how features got added in every version. Okay, so we will be doing that, but you can go ahead with the latest version of Java. You can go with Java 21. What is the use of JVM? Good. So JVM is a Java virtual machine, which is responsible for, it's an interpreter, which translates the bytecode into native instruction set. So bytecode is Java's own instruction set, which they read this bytecode and convert into native instruction set. Let's say if it is running on Windows, it gets converted into Windows instruction set. If it is running on Linux, it gets converted into Linux instruction set. If it is running on Mac, it will be converted into Mac's instruction set. So JVM is responsible for reading the bytecode and convert into the native instruction set. Clear? As we're going to introduce object-oriented programming language today. So it's one of the paradigm actually, and Java follows this paradigm. That's why Java is called as an object-oriented programming language, because Java follows an object-oriented paradigm. Okay. Okay, is this clear for all? Shall we proceed with the next features? Okay, thank you. Okay, let's go with the next features now. So in continuation of the previous slide, the designers of Java set out the development a platform independent language. When Java source code is compiled, the result is not standard executable. Instead, what it produces is called the bytecode. Okay, and bytecode, as the name would suggest, is a series of bytes that corresponds to the machine operation code, which is Java's own instruction set. Okay, and the Java program is executed by sending this bytecode to the Java runtime system, which is called as Java Virtual Machine. There are a couple of questions. What is the difference between Java and JavaScript? Both are different languages. There is no relation between them actually. Okay, as just there's a coincidence that name. Actually, it's not a coincidence. JavaScript wantedly named as Java before, under the name of Java because of the popularity of Java. If you read the history of JavaScript, you will come to know, but there is no relation. Both are different. JavaScript is completely scripting language for web development for the client side, whereas Java is a general purpose programming language. How to download the JDK? I'll explain how to download the JDK. Okay, and okay, fine. Now, so there is another question on the concept what we have learned. Like Java uses both interpreter and compiler, right? So we have Java compiler as well as the interpreter. So what is the exact sequence? Compiler converts the bytecode and then bytecode directly executes by the operating system. Option B, compiler converts the bytecode and interpreter converts into the machine code. Option C, compiler converts the machine code and then interpreter converts to the bytecode. Option D, interpreter converts into the source code and then bytecode. Which option is correct? Option B, right? Okay, the compiler converts into the bytecode and then bytecode we give it to the interpreter, which is JVM, and JVM will convert into the machine code. Okay, you know what is this JIT here? There is something else called JIT. Can somebody tell me what is the full form for JIT? What it stands for? You have any idea? Because anyhow, we're going to discuss today. But anybody here just in time? Okay. What is it exactly? What is this just in time? Is it an interpreter name? Is it an interpreter name? Okay, it's a compiler. Okay, fine. Great. So we will be talking about what is JIT and what is the use of this JIT as well today. Okay. So now going for the next, so option B is correct. So going for the next feature, we know like Java is a simple programming language. Okay. So now let's see like how can you justify that Java is a simple programming language. The first feature we have seen like Java is platform independent, which is one of the most important feature, and that's why Java get into the internet world and gets popularity. Now let's see what are the other features expected in interviews, as well as you can write this in your JNTU exam. If you get question like explain Java features or Java buzzwords, you can write all these features along with detailed explanation and example. So let's see how can we say that Java is simple. So basically, we can say Java is very easy to learn because it inherits many features from C or C++ and removes complex features like pointers. So, you know, like in Java, there are no pointers concept. In C++, we have another complex feature like operator overloading. So it has been removed. Structures, union, or explicit memory allocation, all these features which are actually complex than making the thing simpler has been removed in Java, which makes is a good choice for the beginners and make developers life easy. So this way we can say that Java is very simple to learn, and many of us will be having this confusion like is it Java simpler than C++? Yes, Java himself says that very simple language comparatively to C++ because you will not be finding all these complex features in Java, making it very easy and for the beginners and all. So many people have asked question last time, like, do you need any prerequisite for learning Java? Actually, no. You don't need to have any prerequisite, even though it has actually taken the features from C++, but it's perfectly okay learning Java as the first language. Okay, there is no prerequisite for Java having a knowledge in C++. If you already have, that's great, but if not, then it's not at all a problem. You can directly learn Java, okay, because it's quite simple. Because there are reasons like pointers are actually more dangerous because it violates the security because anybody can access memory and can get the data access, which is actually not good. And structures and unions has been replaced with other things like classes and all, which is more convenient to use. Operator overloading is not required because it's a very complex process. and so it has been removed. So whatever, like even explicit memory allocation has its own disadvantages and all, Varun. So that's why all these features has been removed, because they are more complex or more disadvantageous, having rather than making simpler and advantageous, it's more disadvantages. So that's why it has been removed basically. Okay. If you see the placements perspective, reduce learning curve, because Java is simple. You can faster adaptability during the coding rounds. So you can start solving coding problems quickly. And that is the reason I told you, like, Java is one of the preferred language for competitive coding because of its simplicity. Initially, it may look difficult because you're learning a new paradigm, like object-oriented paradigm, but Java itself is very simple because you don't have complex things. A lot of things are inbuilt. It have a lot of library supports. So keeping all these things, Java says that it's a very simple language. Okay. Next feature is Java is a robust programming language. Okay, Java is a robust programming. Yeah, we will be talking about paradigm today. Paradigm is actually a way of solving a problem. So you have different paradigms like functional programming paradigm, object-oriented paradigm, procedural paradigm. So you have different paradigms. Okay, so we will be talking about it. What exactly mean by paradigm, and we'll be getting into like functional programming paradigm or object-oriented programming paradigm. So moving to the next feature, I would like to see, like, do we have any question on the first feature? Like, is it clear for you all that Java is simple? How is Java still relevant in today's world compared to newer languages like Python or Go? Uh, because still Java is like, because one thing I can tell you, like this Oracle has decided that you will be getting a new release of Java every 6 months. So that way Java is evolving. So I can say that Java is very much relevant to the today's world. Uh, Even Python is actually having a lot of library support and enhancement to the Python as well. But when it comes to the few of the development, like web development or mobile development, even in the placements, coding, competitive coding, Java is still ruling the world. Whereas Python is good for others, like for AI, for ML, for analysis, data analysis, all these things. Python could be a good language for it. But as we have already discussed in day one, like in that scenario, uh, Java could be one of the preferred language for that. Okay, so let's talk about what is a robust basically. So Java is a robust. So robustness, the ability of program to run with low probability of a crash. The two main reason for program failure is the memory management and the runtime errors. Okay, the two main reason why generally application fails is for the memory management and runtime error. Let's try to understand so that we can justify that Java is a robust programming language. Meantime, we have one more question. Like, I want to know what's something that Java can do and Python cannot, because if Java is preferred in many companies, then where does Python stand in companies' needs and use? Akash, basically, like uh, Python is majorly used in AI, artificial intelligence, machine learning, and data analysis. Python did not gain popularity in other areas like web development, even though it has frameworks like Django, Flask, and all. But Java is ruling that world since many years, and we have a lot of good frameworks like Spring Boot, which most of the company uses. So there, Java is one ruling, and the second is in mobile development. Java is the language which was the initial language by which you actually develop for the mobile related, Android related application. Then Kotlin came into the existence, which is actually compatible with Java. So I can say even in mobile development. And when it comes to big data related application and automated systems, Java is still ruling in these areas. Whereas in AI, ML, and data science, Python could be the preferred language. And when it comes to placements coding, Python is interpreted language. It's very slow, and there is a lot of chances to get TLE. So it's not preferred to use Python for competitive coding, whereas Java is the preferred language for that. Okay, so now we will go and talk about yes. So let's talk about what is this robustness, okay, and what are how there's two main reason for making the program crash. So first, let's see that what is basically a memory management and how Java helps for this memory management. Okay, so we'll get into our black screen and let's try to understand what exactly mean by memory management. And whenever we talk about memory management, let's have a comparison with C language and with Java language and see like how memory management happens in languages like C, C++, and how Java take care of memory management. Okay, whenever we talk about memory management, basically you allocate memory, whether it could be for variables or for arrays or whatever the memory you want to allocate. In every programming languages, there are two ways you can allocate the memory. One is called static memory allocation, which will allocate the memory at the compile time. So it's called static memory allocation. Okay, so let's say, for example, if I wanted to allocate the memory for an array in C language, the syntax could be like I'll be using a data type. Let's say I wanted to create an array of integers. I'll be using a data type called int here. Okay, then I will create an array. Let's say I give the name of the array as A and write this subscript. Okay, write this subscript and gives a semicolon. Now tell me, if I execute these statements in C language, will this statement works fine? This is a correct way of creating a memory, an array in C language. Okay, so some of you thinks, yes, it's the right way for creating an array in C language. And few of you thinks, no, it's not correct. So what is missing here basically? What is missing here? Size. Okay, is it mandatory to give size in C language? Yes. Okay, you need to tell them like how much memory you require. So that way I can say it's the way you allocate the memory at compile time is called static memory allocation. I need to tell like how much memory I need at compile time itself. So that way it will allocate the memory. So let's say I wanted to store 5 integer values, then I'll be saying that 5 as the size of the array so that it will create 5 blocks for you. Okay, 5 integer blocks for you. If I say 500, then it will create 500 blocks for you. Okay, 500 blocks of memory. So basically this is called static memory allocation. You know, like what is the major problem with this static memory allocation? Anyone? What will be the problem with this approach? The main problem with this approach is wastage of memory. Okay, because let's say if I have 500 memory allocation, but I will be storing just 10 data, then 490 slots will be wasted. It cannot be reused by any other program. And even if you want to exceed this, you cannot. So it's basically fixed size. You cannot dynamically increase or decrease the size of the memory. There are other issues as well with the static memory allocation. That's why languages do have dynamic memory allocation that can support for allocating the memory dynamically. Okay, let's say if you wanted to dynamically allocate the memory in the C language, if you wanted to allocate the memory dynamically in C language, then you can make use of the functions like malloc, calloc, and realloc, which will actually allocate the memory dynamically, Let's say in dynamic memory allocation, as the memory allocation happens at runtime, let's say I wanted to have only 10 blocks. Can I simply create 10 blocks here instead of creating 500 blocks of memory? Can I ask my malloc function in C language that just give me the 10 blocks instead of giving me 500 blocks? just give me the 10 blocks. And at runtime, I can increase or decrease this value to tell how much memory I require. Making sense for everyone? So, so dynamic memory allocation will help us for saving memory, correct? Just type Y if you have understood. Just type Y. Okay, fine. So do you see any still in dynamic? Do you see any problem with dynamic memory allocation? Still, is there any memory leakage in dynamic memory allocation in C language using malloc, realloc, calloc? Do you still see any memory management issues, or do you see any memory leakage problem with this dynamic memory allocation? Basically, we prefer dynamic memory allocation when you wanted to allocate the memory or you don't want to waste the memory, then you can actually go for dynamic memory allocation. Basically, dynamic memory allocation will be more preferred compared to static memory allocation. If you know how much data you required in before like in hand, then you actually can go for static memory allocation. Whereas in dynamic memory allocation, if you will be always preferred because at runtime you can tell how much memory is required basically. So that way you can always go for dynamic memory allocation. But my question for everyone here is, do you still see any memory leakage or any memory management issue with dynamic memory allocation concept? Okay, let me try to put this in a real-time scenario. Let's say, for example, I have one scenario here. Let's say I wanted to conduct a session. There is a big room, okay, with a capacity of 500 chairs, okay, and you can imagine chairs are like memories. So if I ask Vamshi that please allocate me 500 chairs here, or I wanted to conduct a session, then what Vamshi will do, that he will give me 500 chairs, like 500 memories will be created here now. 500 memories will be created. And this allocation of memory is done before the session starts. So I can call this as static memory allocation. And we have already seen the biggest problem with the static memory allocation is if, let's say if only 10 people comes for the session, then 900 chairs will, 490 chairs will be wasted. Okay, so 490 chairs will be wasted. It cannot be used by other sessions as well. So this is the problem with static memory allocation. So to avoid this fixed size and the wastage of memory, we generally go for dynamic memory allocation. And in dynamic memory allocation, what I will tell, let's say Varun, I will tell Varun that give me data dynamically. So Varun will ask me how many chairs you require, and accordingly he will arrange. Let's say if I say that I want 50 chairs, then Varun will allocate me 50 chairs here now. Varun will allocate me only 50 chairs. Can other programs reuse the other memories left out? Yes, right. So do you see any wastage of memory here? Do you see any wastage of memory? As I required 50 chairs, so I got 50 chairs and 50 people comes in. So do you still see any wastage of memory? But let's say after the seminar starts, so after the session starts, let's say 25 people left out. 25 people left out. Can I reuse that memory? Can I reuse that chairs for other people? If the 25 people left out for that particular session, can I reuse that memory for other people? Actually, no, right? Because the algorithm is whenever the next 10 people comes, Varun will give me 10 more chairs, 10 more chairs. Okay. So I have to manually remove this chair so that it can be reused. So that's why C language gives you function like free function, okay, where you have to call to remove the memory. So you have to explicitly call this free function to deallocate the memory. So whatever the memory is not required, so I have to wait for the session. I have to call another person called free, which is responsible for removing these memories, which is responsible for removing the memory. So it's your responsibility to allocate the memory as well as to deallocate the memory. So most importantly, whenever we make the programs now, whenever memory is required, you keep allocating the memory. You will never care about deleting up the free spaces. The time comes up where the memory gets full and you will get memory overflow error, and your application will get crash. And that is what happens even in your mobile phone, right? You keep daily taking pictures and all. Sometime comes where your memory gets full and you don't free up the unused photos and all, right? And your phone camera may crash because it cannot store more photos because you're not freeing up manually. So this is what the problem with C language, that you have to manually take care of allocation of the memory. Now let us see how Java fixed this problem. Okay, Java fixed this problem. Java says that, okay, you allocate the memory. First of all, let's say if you wanted to allocate the memory in Java, let's say you wanted to create an array in Java. The way you create an array in Java, anyhow, you'll be learning in arrays concept. Just wanted to show you like how you actually create an array in Java. You know, like if I say int a subscript and ends with semicolon, and I write 5 as a size of the memory. Now tell me, is it a valid statement in Java to create an array? The same way I did it in C language for allocating the memory for an array. Now tell me, is it a correct statement? Is it a correct syntax for allocating the array memory in Java? Yes or no? No. Why it is not correct? What is wrong here? What is wrong in the memory allocation here? New is missing. Okay, fine. Meaning, first of all, what's wrong here? You know, the problem is the arrays in Java will be dynamically allocated. Okay, the memory for array will be dynamically allocated because that is what the basic problem with C language, like arrays allocating memory statically doesn't make any sense. So Java has decided that there is no way that you can allocate the memory statically for arrays in Java. Okay, and you always have to allocate memory dynamically in Java. So giving a size will be a problem in Java. Whereas in C language, not giving a size will be a problem. Whereas in Java, giving a size will be a problem. Now let me show you with a quick execution. Okay, here if I go and give the memory allocation for Java, in Java, let's say I create an array int a subscript. I say that give me 5 blocks of memory. Now let me ask a Java compiler and see what Java compiler will tell me. Now if I go to the Java compiler and say that I wanted to allocate the memory for this. Okay, okay, so we are in the command prompt. Now I'll just go here and say, please compile this program and allocate the memory for that particular array. Now this time Java compiler will complain me, oh, something. Oh, okay. Save this file. Let me see the location. Okay. This is not here. Okay. Let me open this one. Okay. There are some other codes I wanted to make. Okay, now let's say I will just be creating int a, and I will just give some size here and ends with semicolon. Now earlier it was running some other program, so it given me an error. Now let me compile this code and see you that something is wrong here, because Java compiler says that it's not the correct way for allocating the memory. So Java compiler will not allocate the array memory at compile time. It will always create at the runtime. So writing an empty subscript is always a valid way because as Sai said, we'll be using new operator for allocating the memory at the runtime. Same like malloc allocates the memory dynamically. Java uses new operator for allocating the memory dynamically. Anyhow, moving forward, we will see what is this new operator and how we can make use of this. We will see that. But Java will allocate the array memory dynamically. So there will be no wastage of memory. But does it take care of freeing up the memory? Yes. That is where the Java says that I have an automated system. So Java knows that people generally forgets to free up the memory, and that is the main reason why generally applications get crashed because of memory management problem. So Java has come up with a solution. What Java says that you take care of memory allocation, I will take care of memory deallocation or releasing of the memory. I will take care. So what Java did is, let's say, for example, if you take out the example of this seminar hall, let's say if somebody tells that you please take care of the memory allocation, I will take care of the deallocation. So Java provides you an automated system called garbage collector, okay, which is responsible for deallocating the memory. So whenever there is memory is not in use, the garbage collector comes in and deletes the memory automatically. You don't have to worry about it. Okay, you don't have to worry about it. So Java says that I will take care of memory deallocation. So there will be no issue of application getting crashed because of memory, because I'll make sure that memory will never get overflow. Whenever there is no use of data, I will be simply deleting up. So that will be garbage collector. So anyhow, this concept we will learn in detail, but this is how this Java take care of this memory management. Okay, so the Java designers eliminated the manual memory allocation and deallocation. Memory in Java is automatically garbage collected. You never have to worry about memory corruption. So you don't have to worry about memory corruption or memory leakage problem because it will be automatically taken by the garbage collector. So garbage collector, you can imagine as a program running in the background, which will always be checking whether memory is in use or not. If it is not in use, simply it will delete that particular memory. So we will be discussing this concept in detail moving forward, but just to make you understand like how Java claims that it's a robust programming language, I have just introduced garbage collector for you. And similarly, Java has one more concept called exception handling, which take care of runtime error. So we have this capability built in Java. So exceptions that would otherwise cause program termination can be dealt with exception handling. So both problems has been dealt with in Java. So I can say that Java is a robust programming language. Is this clear for you all? That how can you say that Java is a robust programming language? Because in interviews, they will be expecting you to justify this concept that if you say that Java is a robust programming language, then you can justify with these two examples, like how Java will take care of memory management automatically and how these exceptions can be handled. Moving forward, we will be having a very detailed discussions on these particular concepts. Today, we just introduced to make you understand one of the feature called robustness. Is this clear for all of you here? How Java is robust? Great. Okay. So now we will have a couple of questions on this topic and then go for the next concept, which is secure. So if you look at from placement angle, error handling helps you to write safe programs for interviews. So it's very important to know how to write programs with which are safe from errors and all. Okay, so that could be healthy. Now, can you tell me, because this question has been asked in Amazon as well as in Oracle Certification Associate exam, which is a certification exam for Java. In Java, automatic memory allocation is achieved using what? In Java, automatic memory management is achieved using what? I thought of asking this question before we discuss the topic, but I hope now you can able to answer. Okay, I'll show the options if you want. Will be using constructor or destructor or garbage collector or new operator? How Java will take care of memory management, how automatic memory management is achieved. Does new operator will be done automatically, or you have to allocate the memory? Okay, garbage collector, that's nice. So option C is correct, right? So garbage collector is one which will take care of automatic memory allocation. Now, related to garbage collector, there was one more question asked in Wipro Elite NTH. Java uses garbage collection for manually freeing up the memory, automatically removing the unreferenced objects, prevent stack overflow, or handle exceptions. What is garbage collection is used for? Which option is correct? Okay. A garbage collection doesn't work on stack basically. Okay. As you know, dynamic memory allocation will happen on heap. So basically it will delete memory from heap itself, not from the stack. So option C will not be suitable for garbage collection. So obviously option B is correct. Okay. So all of you going good. So I hope with this, can we conclude the second feature, which is robustness? So you can justify now like how Java is a robust programming language. Even if you get this question in exam, JNTU exam, you can explain in detail, right? How Java can be a robust programming. Now, before going for the next feature, I wanted to check from your side. Oh, there was one more question. Which Java feature ensure that recovery from runtime errors like division by zero, abstraction, exception handling, encapsulation, or security? Which feature will tell that recovery from the runtime errors, exception handling, right? We haven't discussed in detail, but at least now you got to know that if you have to deal with runtime error, Java has a feature called exception. Okay, great, great. So that way we can see that exception handling is the feature by which we can actually deal with the runtime. Now, can someone say that how can you say that Java is a secured language? This is very important for interviews. You get a lot of questions from this, and it's very hard to justify sometimes saying that Java is a secured programming language. You cannot simply say, right, okay, Java is a very secured, but how Java achieved this security? Okay, so let us see from your side, then I will be explaining. It has protected classes, okay, due to no pointers, no memory leakage, okay, by bytecode verification, okay, great, great. So there are a lot of features in Java which makes Java as a secured language. Very nice, Rajesh. Okay, great. We will be discussing these points one by one. Okay, and we'll also try to understand the JVM architecture because that gives the major security for the Java. Okay, so let us see first. As some of you said that there is no pointers concept. So unlike C++, Java does not allow direct memory access through pointer. So this prevents hackers from accessing unauthorized memory location. Okay, so this prevents hacker from accessing unauthorized memory location. So this way, as I told you, like pointers will allow to access the memory location directly, which can be harmful because hackers can hack your data and get the data collected. So that way, pointers, removing the pointers concept first helps Java to make it secure. Okay, to make it secure. Second, as Vamshi said, like Java has something called bytecode verifier. Okay, what is this bytecode verifier? Bytecode verifier inside the Java virtual machine check the class structure, the control flow, and the data type safety, and access the permission before execution. So this prevents the illegal memory access, stack corruption, and unauthorized access, making Java secured and virus free. I will explain this with one diagram, how things works. If you look at this diagram here, it has like both compile time and execution time. So let us see like what happens, how Java, this is the complete architecture for your Java runtime environment. Now, if you see the compile time thing, what happens, the source code you give to the Java compiler, and we know that Java compiler will convert this into bytecode. So this is what happens at the compile time. Now at the execution time, what happens? We give this to the JVM, right? But before it gets into the JVM, there are something called class loader and bytecode verifier. Yeah, Mohammed has any question? He has raised his hand. If you have any question, please let me know. Okay, so these things will add security to the JVM. So what bytecode verifier will do is it will verify whether the bytecode what it got created by the Java compiler, is it a valid bytecode or not? If it is not valid bytecode, it will be rejected and it will not be interpreted by the JVM. So that way it will add a security. It will add a security that no other bytecode. So let's say some hacker will create its own bytecode and claims that it's a Java's bytecode. The JVM will easily recognize and it will not allow to execute that particular code. So that is adding a security here. Sure, I'll do that. I hope I'm going very slow, but still, if you think like that, I'll make it quite slow. Please stop me any point of time and please ask me any question so that I can explain once again. Okay. Any of our bytecode verifier, I just move ahead so that I can make you this diagram and then I can go back and explain you the bytecode verifier once again. Okay. So basically what class loader will do is it will first load the class, initialize all the memories required. Okay, and at the type of class loading itself, it will check whether the dot class file is a proper way or not. So this adds the security level. It will not load the dot class file if it is corrupted. So it will not load the dot class file itself. Even if this passes, then bytecode verifier will verify whether the bytecode is generated by the Java compiler or not, or it is by the unauthorized sources. So that way, after checking up these two levels, it will give either to JVM or JIT, just-in-time compiler, which will convert into the native instruction set, and then the operating system executes and gets you the output. So basically, this will add the security level. So the class loader mechanism, what it will do, the Java has a class loader that loads the class dynamically. It separates the local class file from the network downloaded files. So if any hacker or anybody creates the own dot class file, it will avoid mixing of the trusted and untrusted code. So let's say downloaded dot class file or jar files from the internet can run only if the JVM allows them. So this has the security for it. So this way we can say this class loading mechanism or the bytecode verifier will add a security here that no one can actually easily create viruses and everything. So that's why very oftenly they ask this question in interview, like why is Java called secured? You can say that because of this bytecode verification, having no pointers concept, garbage collection concept, the class loader concept, and security manager, Java achieves security. And that way we can say that Java is a secured language because no virus, you cannot easily make virus programs in Java compared to C++ because they don't have these features. So that way in C++, making virus programs are quite easier. And even hacker prefers C++ programming languages because of these features like pointers and all. That way they can easily make such kind of things. But whereas in Java, it is secured because it does not allow all these things. So is this clear for all? Now can you justify like how Java is a secure programming language? Just a quick response from everyone here. Now, last three are mostly for companies' perspective. Let's try to understand uh, because of these features, basically Java preferred in most of the companies. So let's see what are these features are. But again, before moving, just to conclude the topic and wanted to check from everyone, we'll be having a question. It has been asked in Cognizant. Which of the following best explain Java security feature? It has no pointers. It has bytecode verifier. It has automatic memory management. Which one is correct? Which of the following best explains Java security? Option A, option B, or option D? Option D, right? Correct. Because of all these, it has no pointers. That's adds the security. Bytecode verifier adds the security. Okay, and automatic memory adds more security for the garbage because it will not allow to access the memory again. Okay, so that way all these features will allow for the security. Okay, so option D is the correct answer. Good. Now it has a lot of libraries. Okay, we call them as APIs. So Java provides various pre-built tools and libraries, which is known as Java APIs. That is where Java is very popular for, because Java has numerous libraries which is used for tasks like file handling. For networking, we have uh, libraries available. For database connectivity, for security, for everything. Java has a lot of libraries available. With the help of these libraries, developers save a lot of time and ready to use the solution and can also build a powerful application. So interviewers often ask practical coding questions on API usage like array list, hash map, on streams, etc. So knowing APIs is one of the very important thing for Java language. Okay. So this way we can say that Java has rich standard libraries, making it one of the preferred language for development perspective. Now, what do you think? Before we go for this, there was a question in Amazon. Uh, Java was strongly object-oriented till Java 7. What changed in Java 8 that made it hybrid language? Can someone answer this question? Java was a strongly object-oriented programming language till Java 7. But what happened in Java 8, what changes happen in Java 8, which becomes the hybrid language? Do anybody knows? This is what you need to actually upgrade yourself, right? Because anyhow, we'll be talking about it, but you can just have a guess if you want, or if you already know about it, you can tell me. Otherwise, anyhow, we're going to talk about it. Which specific feature has been added in Java 8? Since then, Java becomes like a hybrid language rather than a strongly object-oriented language. Java 8 introduced okay, functional programming features. Nice. Okay, so basically added functional programming features like lambda, streams, and functional interfaces. So that way, now Java is not a strongly object-oriented language or pure object-oriented language. There is a debatable question like Java is a pure object-oriented language or not. But at least we can say Java was strongly object-oriented language. But after Java 8, now Java is a multi-paradigm programming language because Java supports both object-oriented programming and functional programming. Okay, so let's quickly see what is functional programming. So Java was traditionally an object-oriented language, but with Java 8 and beyond, it uh, embraced the functional programming features, making modern expressive and placement relevant. And that is where Java can basically used for now Java is no longer just object-oriented programming. It's object-oriented programming plus functional programming. So that means you must learn both worlds to stand out in placements and global certifications. So now you should know what is object-oriented programming features as well as what is functional programming features. And that is where actually functional coding style is now standard coding for interviews. So mostly you will be getting question in interviews from lambdas, IO streams, and functional interfaces, which makes Java a functional programming as well. Okay, so we'll be discussing, this is not a part of your regular academic syllabus, but we will be discussing this additionally as placements perspective, like how Java supports functional programming. So I'll be teaching you like what features added in Java 8, what features added in Java 9, Java 10, all these 11, so 18 and Java 21, what features added in every version of Java, we will be talking about it. So mostly interviewers will check whether you have upgraded yourself or not, because that's how you can differentiate between a regular JNTU student and others. Because if you know enhancement happens in every version of Java, then you can justify the increase. Yes, Java is a multi-paradigm. At least I can say it's a hybrid language because it supports object-oriented as well as functional programming. Same with Python as well, because Python is also a multi-programming paradigm language because it supports both object-oriented, functional programming, procedural. So I can say Python is also a multi-paradigm programming language. Clear with this, guys? Did you all understood why Java is also a functional programming paradigm? How Java call as functional programming language as well. We almost covers almost all the features. Now we will be stepping into object-oriented programming where our actual journey will start with. Which of these features, simplicity, security, robustness, uh, object-oriented functional programming, do you think make Java most popular today? Paradigm means the way to solve the problem, basically. So object-oriented is one of the paradigm, is one of the approach for solving the problem. Functional paradigm is one of the approach for solving the problem. So every language has to follow some paradigm, some approach for solving the problem. So it's a paradigm is the way of solving the problem. Okay, actually that is our next slide. I'll be talking about the paradigm, but I will be stepping into object-oriented programming. Okay, that's nice of you, Vamshi. Okay, so any more questions, guys? Till now, is this clear? Can you all able to justify like why Java is simple, robust, secure, how Java has rich standard libraries and functional programming features? I hope you can talk more in detail about these points now, as well as you can explain on your exam, like how these features will help you. How will companies ask about functional programming? Obviously, they will ask you because most of the codes they'll be expecting you to write with functional programming, Shravani. So knowing functional programming is very important. Like they will ask you what are functional interfaces, how you can write Lambda function, even a lot of things like writing latest codes will be expected to be in functional programming approach. Okay, I told you in my previous slide that in this modern era, they'll be expecting you to write the code in a concise way where functional programming will actually helps you. So most of the things has been changed. So after getting into Lambda expressions and functional interfaces, now the coding style has completely been changed. So that way you should able to write code in that way if they expect you to write that. Or they may ask direct questions on these features like what is functional interfaces and how it works. All these kind of questions you make it directly. But we have a concept learning as that's the beauty of these sessions because we will be learning all these additional concepts here because we are not here just for JNTU. We'll be here for placement. So I'll be covering all of these concepts moving forward. This is just an introduction, Shravani. Okay. This is just an introduction. We haven't covered functional programming yet. All these just an introduction to make you understand like because of these features, Java is popular for. Okay. So moving to object-oriented programming, as you know, like Java and your subject name itself is object-oriented programming through Java. So Java is said to be strongly object-oriented programming language. In Java, everything is an object. It supports all the features of object-oriented programming paradigm, like encapsulation, polymorphism, inheritance, abstractions. These are the basic main features or the principles of object-oriented programming. Whoever follows these features and characteristics, it's called it as an object-oriented programming language. But it's not purely object-oriented because the primitive data types also implemented as object in Java, which we call it as wrapper classes. We'll see in our feature classes. But still, it allows primitive data type as well for high performance. So that way, Java is not pure object-oriented language because giving support for primitive types and all. Whereas in Python, everything is an object. So I can say Python doesn't have primitive types, whereas Java has primitive types. So that makes Java not as a pure object-oriented programming language. So in placement perspective, they will ask you these questions very frequently. Is Java pure object-oriented programming language, guys? Yes or no? Is Java a pure object-oriented programming language? What do you think? How would you answer this question? No, no, no. Okay. Okay. So it's wrong to say yes. Okay. Because before Java 8, Java was strongly object-oriented, but not pure. But from Java 8 onward, Java becomes a multi-paradigm language. So now it is no more a pure object-oriented language, or even it's not strongly object-oriented because it is multi-paradigm language. Got it? Like how, what kind of questions you may expect from placements perspective on object-oriented approach? Great. What does it mean that Java is both object-oriented? Because you can write programs in both approaches, Vamshi. You can write programs in object-oriented style, which we will be learning from now, actually. Next topic was introduction to object-oriented programming. You will see how to write codes in object-oriented style. And functional programming has a different approach, actually. Okay, so both approaches are different. So Java follows both from Java 8 onwards. Vamshi, functional programming paradigm also got added. So you can write in that way, in that approach as well. So both are two different approaches for writing the problem. So that's why we can say Java is both object oriented as well as functional programming. So it supports both features. So we actually supposed to get into a question here. Why Java is not considered 100% object-oriented language? Because it does not support operator overloading, because it has primitive data types, because it does not support multiple inheritance, because it uses bytecode. Option B is correct, right? Because it has primitive data types like int, float, and all for high performance. So that way Java is not 100% object-oriented language. So you see, it has been asked in Infosys and many companies. It's a very popular question, like why Java is not considered as 100% object-oriented language. You can justify telling this. Okay. So with this, we will be stepping into object-oriented paradigm. But I think it's a big topic, so I don't want to start now. So I can start this concept in next class. What is exactly object-oriented programming paradigm? For now, I would like to take up another topic, small topic for the day. And also I wanted to take up a few questions to conclude. Even Python has primitive data types? No, Python does not have primitive data types, guys. Okay, before I go for the next small topic, I wanted to take a few questions here. But we have wrapper classes in Java, yes. But still it supports primitive for high performance. So that's why we can say that Java is not 100% object-oriented language because it supports primitive still. Still you have this int, float, and all. You'll not be using classes, right? Whereas in Python, you see all data types you use are classes. Like int is a class in Python, float is a class in Python, and all data types you use like set, okay, dictionary, all these are classes in Python, so it doesn't have primitive types. Clear with this? Any more questions from today's topic? Do we have any more questions from today's topic? So we have covered. Does it same for C++? C++, yes. It's also not pure object-oriented language because it supports both procedural as well as object-oriented style of coding. So it's not a pure object-oriented again. Okay, it does have primitives again. Okay, it doesn't have wrapper at all. So that way C++ is not pure object-oriented programming language. But yes, C++ is also an object-oriented programming. We will be stepping into practical. That will make sessions more interesting. Okay. So I thought I'll cover two of the concepts, but I hope I'm going slow so that I can at least tell you the importance of the things and how you could take things in placement. So I'll be adding placements oriented questions or certification oriented questions here so that you can check yourself, like, are you getting ready for placements and certifications as well along with the JNT. So whatever the topic we covered today, you have seen a lot of questions from interview perspective. And also it's one of the very important concept for JNTU or academic perspective. So this will give you a good hold. Okay. So anyhow, still I can see some time is left out. So I'm so confused about purity of object oriented. Can you clear it feature? Because now you can see that Java is not pure object oriented because now it supports functional programming as well. So you can say that as it supports functional programming as well as object-oriented programming. So now it's multi-paradigm. It's not pure object-oriented programming. Even earlier, it was not pure because of support giving for primitives. But now you can say after Java 8, you can proudly say that Java is not a pure object-oriented programming language because it do support for functional programming approach as well. So it's a multi-paradigm programming language now. So I guess it's clear for you. Then I'll tell my journey of learning things as a conclusion for today's session. But why C++ is hugely used for solving DSA while having these many benefits with Java? Okay. First thing I wanted to tell you, Shruti, C++ is comparatively faster than Java because it's close to operating system. So it's quite fast. So that is the reason, one of the main reason why C++ is majorly used in the competitive coding, especially for solving DSA and all. And another reason why C++ is very popular because before Java, C++ has one of the library called STL, Standard Template Library, which became very popular because it has a lot of built-in data structures like vectors, stack, queues, and all. That will be very useful for DSA related problems and optimization of problems and all. That way C++ gained the initial popularity in the competitive coding. And that way people still prefer C++ because people, instead of writing it in object-oriented style, they will prefer to write it still in procedural way because that they don't want to get into the complication of object-oriented syntaxes and everything. So that's one of the major reason why C++ still prefers for DSA problems and all. But again, let me tell you, it's not completely true. Java is equally preferred, even though it's a little slower than C++, but because of these features, it is very, very useful. But on the development side, Shruti, you see, comparative with C++, Java is like somewhere far away from C++ because C++ is never be used in development much, except some gaming applications and all. C++ is not into the development. But still in coding, people prefers for C++, but many are coming out of it. Even, you know, most of the organizations now teaching DSA with Java, not with C++. So even I started my journey with Java actually. So when I completed my course, that time C was very popular. We were learning C and teaching C and all. Then I get into Java, okay, and I started liking Java. Then I have learned all Java related technologies, especially the advanced Java like servlets, JSPs, Spring, okay, and then in 2014 and all Spring Boot came, and then I explored. And also, when I joined in my engineering, my principal told me that if you do not update yourself, you cannot be a computer science engineer. So I remember that every time I try learning new things. So after that, when I get into my first job, the first opportunity I got teaching Android programming in 2012, 2013, I got a chance for teaching Android programming for mobile development, which was in Java, because I love Java a lot. So I started my career with Android programming and as a Java developer. Then parallelly, I have learned other technologies as well. Even I have learned C Sharp. I've learned some web-related technologies, both front-end, back-end, React.js, AngularJS. Even I have learned Python because first machine learning code we have written in Java, but we know the pain. So that's why we switched to R because that time R was very popular for data analytical work. Then Python gained popularity. So even I learned Python for machine learning and data science related applications development. And we have to keep learning, Vamshi. So that's how my journey is all. Still, I have to keep learning things. Okay. What will happen? There was a question here, like, yeah, actually, this was the question which I have shared in the group. It will give you an ambiguity. The reason is when you just call 10 and 10, how Java compiler will look actually is, first it will look for the exact match. Now, can you tell me like what you are passing here, 10 and 10 is of which type? 10 and 10 is of which type now? So 10 and 10 is of integer type. Do we have a method of both integers? Do we have method for both integers? No, right? We don't have methods which takes both integers. Then Java look for widening. Java look for widening. But in widening, there is an ambiguity problem because one exact match, one widening is possible. Here also one widening, one exact match is there. So that's why Java says that no, there is an ambiguity. So it will give you a compilation error saying that no method is applicable for that data passing because both having an ambiguity. If you remove one of them, then it will work. If you remove one of them, it will work because one will be exact match, one will be the widening. The compilation error is just because having two methods where they can have an exact match and widening. So one parameter with exact match, one parameter with widening. Because of that, you will get error here. So that code will give you a compilation error because of that. Anyhow, we will be learning when we go for method overloading, because in JNT you will only be learning about how method get exact match. But in interview perspective, there are other things to learn like how widening happens, how wrapper classes can be used, and how variable length argument can also used. So all these things we will be learning. So here we will always be learning things in detail. So that will help you for placements as well as for certification questions to be answered. So thank you all for having your questions. I hope I have justified answering all of your questions. Can you guide as a second year student? I'd like to know what areas in Java or other languages we should focus on more in this stage. Now you please, you are from which stream, Vamshi? Then I can guide you. Even you can come and meet me anytime. I can give you for CSE. Now I can say, Vamshi, please concentrate on Java language. Okay. It's going to be one of the most important language for you moving forward. You can go for advanced Java where you can learn Spring, Spring Boot, Hibernate. That will help you for the development and all. Meantime, I'll guide you on what else you can learn beside this so that you can become a good developer. But Java itself will have enough for you to get good placements of 20, 30 lakhs of packages. Java itself will be enough for you. But if you wanted to make your career on AI, ML and all, then you have to move towards Python. Otherwise, Java is more than enough for development perspective. But I can give you more insight if you can meet me at my office. I can give you more insight about like what you can do. But currently, you please focus on Java. You can have a very good score in your academics as well as you get strong foundation in Java so that you can start building some good applications going forward in Java itself. So I strongly recommend for CSE and IT people to focus morely on Java. Whereas for data science and AI/ML, I can say, okay, for development perspective, you can work on Python. But for coding perspective, Java could be your first choice. Okay. So anyhow, you have to learn for academics to get pass and to get score good marks. Other than that, it will help you for placements as well. Okay. So great. Good night, everyone. Thank you all for joining this time. Have a good night. Please ask your friends as well to join on Saturday because we'll be discussing object-oriented programming and we'll be writing our first object-oriented program, which is very, very important. Okay, so please help your friends joining this session so that they also get benefit out of it. Okay, thank you and have a good night. I'll take a leave for the day.